Good morning dear students. In today's video we will discuss exceptional electronic configuration. So I have taken two examples here, chromium and copper. So if we talk about chromium, so chromium comes after vanadium and vanadium has 3 electron in 3D subshell. Okay, so that's why the expected electronic configuration for chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 3d4. Why 4? Because it has one extra electron than vanadium. That's why I have written 3d4 here and 4s2. But actually it does not show this type of electronic configuration. The actual electronic configuration of copper is chromium is this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Means one electron of 4s suborbit is transferring to 3d subshell. Okay, that's why it has 5 electrons in 3d subshell and only 1 electron in 4s subshell. Now if we talk about copper, so again copper has a 29 electron and comes after nickel, which has 28 electron, and nickel has 8 electrons in 3d subshell. So we are expecting, definitely we are expecting this type of configuration from copper, which is 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2. But actually it shows this type of configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Okay, so again 1 electron of 4s suborbit is transferring to 3d subshell. Okay, and it has 10 electron in 3d subshell and only 1 electron in 4s subshell. So now first we see that why these electrons of 4s orbital are transferring to 3d subshells. Okay, so the reason behind is that actually all the element which are present in nature has tendency to attain maximum stability. Okay, and completely filled orbitals and exactly half filled orbitals has more stability than any other type of distribution. Okay, so that's why we can say that to attain more stability they are showing this type of abnormal behavior. Okay, this type of different configuration. I will explain you. If chromium shows this type of configuration, suppose this is the electronic configuration for chromium, so for this configuration we can distribute electron like this, as it has 4 electron in 3d subshell. So 1 electron in first orbit, second electron in second orbit, third electron in third orbital, and fourth electron in fourth orbital. So it has 4 electron in 4 orbitals, and here 1 orbital is vacant. Okay, so this configuration is neither completely filled nor exactly half filled. But if electron of 4s orbital is transferring to 3d subshell, then it will have 5 electrons in 3d subshell. Okay, so 5 electrons can be distributed like this. So in this distribution you can see that it has exactly half filled orbitals. Okay, chromium will have exactly half filled orbitals, which has more stability than this configuration. Okay, again for copper, if it has 9 electron in 3d subshell, then 2 electrons in first orbital, 2 electrons in second orbital, 2 electrons in third orbital, and again 2 electron in fourth orbital, but only 1 electron in last orbital. So it is not completely filled or half filled. Okay, so if electron of 4s orbital transfer to 3d suborbit, then it has 10 electron in 3d subshell, and 10 electrons means completely filled. Okay, completely filled orbital. So it will have more stability than this configuration. So that's why we can say that for chromium and copper, to attain more stability they are doing so means they are showing these type of exceptional configuration, okay, in which one electron of 4s suborbit is transferred to 3d subshell. Okay, so this is the exceptional configuration of copper and chromium. Now we'll discuss that why fully filled orbital and exactly half filled orbital has more stability, okay, than any other type of configuration. So the reason behind the extra stability of completely filled and exactly half filled subshells are these. First is symmetrical distribution of electron and second is exchange energy. Actually, if the electrons are distributed symmetrically, it is scientifically proven that if the electrons are symmetrically distributed, then electron will have more stability. Okay, so as we know that half filled orbitals or completely filled orbital shows more symmetrical distribution than any other type of distribution. That's why we can say that chromium and copper shows exceptional electronic configuration, because they want to show symmetrical distribution of electrons to attain more stability. Okay, now second reason is exchange energy. So before we discuss this point, remember this expression in your mind, always in your mind. Okay, that is stability of any system or stability of any element is inversely proportional to its energy. Okay, so means system which contain least energy will have more stability. Okay, now what is the exchange energy and how it enhance the stability of element. So first of all, what is exchange energy? So electrons with same spin and belongs to same suborbit has tendency to exchange their position. Okay, and in exchanging their position, they release some amount of energy, and that energy is known as exchange energy. Okay, so it is clear from this expression that if the exchanges, if the number of exchanges will higher, then the value of energy released in each exchange will obviously more, and if the energy released is more, then stability will definitely more. Okay, so we can say that larger the number of exchanges, greater will be the energy released, and it will enhance the stability of orbital or system. So if we talk about this type of distribution which is not completely filled or not exactly half filled, so for this distribution, let's see how many exchanges are possible. So for first electron, 3 exchanges are possible, means it can change its position with these 3 electrons. Okay, so 3 exchanges are possible for first electron. Now if we talk about the second electron, it can exchange its position with these 2. So for this electron, 2 exchanges are possible, and for third electron only 1 exchange is possible. So for this distribution, total number of exchanges are possible 6. Okay, but if the electron are distributed like this, means exactly half filled, then the number of exchanges, let's see, for first electron there are 4 exchanges which are possible, for second electron 3 exchanges, for third electron 2 exchanges are possible, and for fourth electron only 1 exchange is possible. Means for this type of distribution, for this exactly half filled distribution, total number of exchange possible are 10. So obviously more exchange means more stability, because in each exchange the electron will release some amount of energy. Okay, and least energy means more stability. So more the number of exchanges means more stability, we can say. So that's why chromium and copper shows this type of exceptional configuration, because half filled or fully filled orbital shows more exchange than the any other type of configuration. So these are the 2 reasons behind the more stability of fully filled and half filled orbitals.